Okay, a continuation on our prerequisite section 1 with expressions, uh, models, and I believe just talking about real numbers. All right, so we start off, with a recap on graphing. The graphing part should be fairly easy. Again, just a reminder, if you do not know what a number is off the top of your head, for instance, the square root of 3, right, you should get a calculator out, type it in there, and see what decimal that is, because we know how to put a decimal on the number line. I already provided you a number line. I already got the arrows pointing both ways. However, I did not include everything else you need. All right, for instance, right, you always need a mark where 0 is going to be, and then remember to give me your scale and actually put the points on the line. Now, a little new in this one is, right, the directions say indicate what group the number belongs to. Is it rational, irrational, natural, whole, an integer, or real? Right, we talked about these categories. Right, now, first and foremost, right, my advice is to work probably the biggest way down. Right, the biggest group. Right, remember, if we go back to what we were talking about, every single number that we're going to talk about and see in this class is either real or not real, imaginary. So that's the first biggest one here. Real, well, are the numbers, is the number -1? We'll just do -1 in this case. Is the number -1 real? Yeah, it is. So this is first and foremost, a real number. All right, again, that's going back to like if I try to explain this as maybe thinking about species, right? Either you're human or you're not human, right? Real being human. Okay, well, once you're identified as human, then, right, we then identify you. The next largest category would then be your gender, right? Are you male or female, right? We talked about those as being our rational or irrational. Those are the next two biggest sets. So if a number is real, it is either rational or irrational. It can't be both. All right, so we go to the number -1. We ask yourself, is that rational or irrational? The right answer is this one is rational. Remember, rational means the number can be written as a fraction. Irrational cannot be written as a fraction. Well, any number, plain number, can be written as a fraction because, right, I can just do -1/1. Isn't that the same thing as -1? Or I can do -2/1, or sorry, 2. What's -2 divided by 2? That again is -1. All right. So then we keep on working down. So it's either rational or irrational. Then our next biggest set here, remember, is the one that included negatives. Right. The ones that include negatives are our integers. Right. Well, is this number negative? It most certainly is. So this is an integer. All right. The next biggest one was the counting numbers. The counting numbers that start at 0, right? Easy way to remember that, whole, right? Well, is -1 a counting number that starts at 0? Well, no, because it goes 0, 1, 2, 3, 4, 5, right? Can't be that. Okay, so we have to stop here. And then the smallest one is natural. Well, if it's not whole, it can't be natural, right? Because every whole number is a natural number, right? Natural numbers are whole numbers without 0. Okay, going back to our properties, right? Looking to see what's happening. 1 plus 0, 0 plus 1, right? We see that this is just the identity property of addition, right? Nothing's changing. Right? Identity means adding by 0 for addition or multiplying by 1 for multiplication. All right, simplifying. This is the one I want to talk about over here because this is where most people tend to make mistakes. All right, most of us know we need to distribute. We know we need to distribute. However, this is the mistake we make. You always need to take the sign with it. All right, if it's positive, you can forget to do that, which is okay. But if it's negative, you cannot forget, right? Because now this is negative 18x plus 21, which just completely changed your problem. And you bring down the negative 5x, right? We combine our like terms, a negative 15, or sorry, negative 5 and a negative 18 would be a negative 23x plus 21. We can no longer combine any like terms, so we're through. Evaluating. Right? Evaluating is nice and easy. All you're doing is plugging in what it says. All right? Everywhere I see an x, I'm plugging in a negative 1. Okay, I see an x here. I see an x here. Everywhere I see a y, I'm plugging in the number 4. And that's it. And remember, when you plug a number in, you need to put parentheses. So 2's there. All right? X, I'm plugging a number in. So parentheses, negative 1. Plus 4, plugging a number in, parentheses 4. Plus 3, plugging a number in, parentheses negative 1, minus 2. Now it's just the order of operations. Multiplication first. Negative 2 plus 16 minus 3 minus 2. Addition and subtraction, you just go down the list. Negative 2 plus 16 is a positive 14. Minus 3 is 11. Minus 2 is 9. So we get a 9 there. Okay, finishing up, we talked about intersections and unions. Again, looking at our signs, the U, right? When we see a U, that is a union. When you see an N, that is an intersection, or it looks like an N and looks like a U, right? They're really not that. All right, so let's start with the union, because the union is truly, I think, the easier one, right? Union says, give me what's in both. I want everything in both, either of them. So just start in each one. In A, I have 2, 3, 4, 9, 6, negative 1. All right, now move down into B. All right, and if there's duplicates, you don't need to include them. So I have 4. Well, I already have a 4 in there. I have dog. I don't have dog in this intersection, or sorry, union yet. 2, I already have a 2 in there. Negative 3, I do not have a negative 3, so I just add a negative 3. All right, and there is my union. Second thing we then need to look at is the intersection. All right, the intersection is different, right, because the intersection wants what's in both. All right, so we need to see what duplicates there are. So in A, I see a 2. In B, I see a 2, so that would fall into my intersection. I see a 3 in A, I do not see a 3 in B. I see a 4 in A, I see a 4 in B. 9, 6, negative 1. Dog, no, they do not combine. So then my intersection of A and B would be the numbers 2 and 4. Okay? And then finishing up, we're just writing an algebraic expression to model what we see. So 6 fewer than a number. So again, just highlighting what we see. Fewer, we know means subtraction. All right, so I know I'm going to be subtracting. I know I need to subtract 6 and this number. Well, I don't know what this number is. I'm going to call that x. Now the question becomes, is it x minus 6 or 6 minus x? Well, really read what it is saying. 6 fewer than a number. 6 fewer, meaning I'm taking 6 away. So the 6 needs to be negative. Right? This is saying a number less than 6. A certain amount less than 6 is that bottom one, not what we want.